Thank you, Chair, for the nice introduction, and thanks to the organizer for inviting me at this beautiful event. As said, we are going to talk about scalable and ambient air processing of printed perovskite PV modules. I will introduce you my research group, the Center for Hybrid and Organic Solar Energy, and then I will talk about the upscaling from lab scale cells to modules, and in the end I will show the results about the fully printed module. My center is located in the Vergata University campus. Our main objectives are the printed electronics applied to organic, dye sensitized and perovskite photovoltaics. So we mainly focus on the device design on the scaling up of the PV technology, and also helping the industry by doing some technology transfer. And so for this we funded some spin-off, some startup and so on. So the photovoltaics is the main input, but this permits us to work also on other fields, as for example, the energy storage, the printable thermoelectrics, the light efficiency, and so we can find new applications. We can test new materials, new processes and machines. The real exploitation at the market level of the perovskite photovoltaic technology can be feasible only if the small lab scale cell will get into the module. The module is, as maybe you know, is an interconnection of different cells with the schematic that you can see in this picture, top right. So we have to interconnect the different cells, and we cannot do a very big cell for the scaling up because of the front contact sheet resistance. So is commonly adopted this P1, P2, PT strategy, when where with the P1 we can insulate the different cells that we are planning to realize. Then with the P2 we can remove the full stack that we deposited on the on the substrate, in this case is a conductive glass substrate, in order to get the interconnection. And after the evaporation or the deposition with some printing technique of the counter electrode, we can have the last laser step, that is the P3, where we insulate the counter electrode. So during this scale-up journey, we can have some issue. One of these is the front contact sheet resistance, as I already said, and we have to design and work on the cell series connection and also about the cell width. But we have also issue related to the interconnection, the area, for example, interconnection resistance. So we have to optimize the laser process for this. And last but not the least is the layering homogeneity that raise up when you are going to scale to a bigger site than a small lab scale cell. And here we optimize the printing technique, the material composition and deposition environment. This is one of the last our work where we compare by using the life cycle assessment method different deposition technique that usually people use in the perovskite PV technology. That are mainly the spin coating, the blade coating, the slow die coating technique. And as we can expect, the meniscus coating technique, I mean for the blade, so and the slow die coating technique, has the low eco profile impact, and so because of the low electricity consumption and mainly also the low material wastage. So our research was focused on to have the full stack of the perovskite, of a perovskite cell that can be printed. Here you can see an NIP configuration. So we have ETL. That here is a combination of compact CO2 and tin oxide. Then we have the perovskite passivation layer and HTL, in the end, the gold. About the process, about the deposition process of the perovskite, that here is from a Medinium-based perovskite, but we use this